Okay, here is my creative project for Physics 42. It's a 1.5 volt battery charge indicator using 4 LEDs right here that will light up depending on the amount of juice left in the particular battery that's being tested. It's adapted from a video from YouTube by Electroluke. That's the guy's name, I guess. And the schematic is behind it. It uses an LM324 quad op amp with some voltage dividers and 4 LEDs at the end, as I mentioned, to get an output that will either light up or not light up each of the 4 LEDs depending on how much of the test battery is giving any kind of voltage output. So it's pretty fun to make. It was kind of tricky, mostly in that I had no idea how an op amp worked, and I still don't really know the regular use for an op amp because I spent most of my time learning how it works as a comparator. Maybe it would have been good to figure out how it works normally, but I focused more on how it works as a comparator. So I'll talk a little bit about that. As far as I understand, which is not that far, but it goes a little ways more than what I started with for sure. I have, like I said, that quad op amp, which is that little chip right there. Has 4 op amps in it, so I've labeled those A, B, C, and D, and they correspond to the LEDs at the end there. A, B, C, and D as shown. And I have another diagram that shows how the actual op amp works. So here's one op amp. So the inverting test pin is the plus sign right here, and that's actually going to be the part of the chip that gets the test voltage from, in this case, the battery, or the potentiometer is what I used for the video or demo purposes. And the chip is going to compare the voltage in to the inverting input to the non-inverting input, which is denoted by this little negative sign here. And the voltage divider is going to give that non-inverting input a reference value. So this input needs to be greater than this input in order for there to be a positive output. And then a negative output is going to be intercepted by the LED, which is going to be the diode. Super crude understanding of this, I'm not totally sure, but basically the chip is going to compare the two incoming voltages, and if it's greater than, you're going to get a lit up LED. So we have 4 of those operating and different voltage dividers on each of those 4 op amps to tell the chip whether or not to light up a particular LED with the output voltage. Kind of, I guess, anthropomorphizing it, but that's how the op amp works as a comparator. Let's see. So the test battery in the video is going to be shown here. It's a potentiometer, like I mentioned, just so I can kind of choose the voltage and show that the LED will light up at a particular voltage, depending on how much juice the battery, quote unquote, has, I guess. So in this case, you would hook up any battery you'd like. Maybe I'll try to do that I have some AA's, but I don't know what the whole point of the potentiometer was to eliminate like arbitrary charges on a battery that I just pulled out of nowhere, and I wanted to be able to show that it actually lights up the LEDs at the expected voltage outputs from the chip. So I have a table with those numbers, but kind of transferring back over, probably translating the schematic to the breadboard was like the most important part, obviously, but also challenging. I tried a couple times on a smaller breadboard, and it was really my first time working with a breadboard, so that was tricky. And I need to go back and kind of troubleshoot that breadboard, but I just outsourced for some help from a friend who has a larger breadboard as well as this cool Arduino voltage regulators. That's what I use to do the 5 volts in. So the chip itself has its own voltage that helps that actually powers it. So the input is on this side and the output's here. And then the pinouts from each of the op amps are the 3 on the left and the right, and then the bottom here. So the bottom left is D, so that's going to be our 100% charge, and then C, the 75% charge. B is the 50%, and then the 25% is this area over here, which is the A. So all of the pinouts are hooked up to the corresponding voltage dividers over here with the resistors and how they're organized. And then the outputs, if we're getting an output, are going to travel along here through the 220 ohm resistor and into the corresponding LED. So the red, I decided was going to be the 25% or less charge. This first yellow, 50%, 75%, and then the green is going to be a fully charged battery, or in this case, getting the full 1.5 volts from the potentiometer. So it's kind of a window almost, like if it's between 75 and less than about 100, this LED is going to light up. So it's not just 75, it's not, I'm hesitant to use the word window because I realize that there are window, you can kind of program or design your circuit to do a window, so I'm not sure that that's what this, this wasn't what that was. This is just sort of, at a minimum, it's getting 75% if this one's lighting up, and less than 100 if this one's not. So anyway, that was an aside. But that's basically how it works. And in a separate video I'll show you with a meter that at the correct, pretty close to the correct voltages, the LEDs do light up one by one. So now, let's see, just at, when all of those are lit up like that with the green, that means that the op amp is getting, or all of those little, this specific particular, I guess, op amps within the chip are getting the required voltages to give an output that lights up the LED. So, I don't know, I think it's pretty cool. I was pretty excited about this when I finally got it to work. So I'm going to talk a little bit about the design. I think I mentioned I got it from YouTube. And initially I thought I would just kind of give, oh, that's where the 5 volts. So the 5 volt regulator powers the chip and it also gives power to the voltage dividers over here. So it's giving our, let's see. Yeah. So the 5 volts are going in R2, and then R1 goes to ground, coming out. And then that's the reference voltage that goes into the little chip, the op amp. And then this is the test battery voltage going in. So that's what we have translated over here. If we'll take a look, some input, and then this is the output. So 1, and then 8, or wait, where's 8? 1, 7, 8, and 14 are the outputs. So those are the white and the red there. And then the yellows, like I said, go to the LEDs. And then the voltage dividers are set up as needed. I had to use several different resistors for a couple of them, so that was fun, putting those in series. But it worked out, so it was good. Okay, back to the drawing board. So I had done this little scale to figure out how much of a 1.5 volt battery 25%, 50, 75, and 100 would be, as shown. And initially, like I said, I thought I would just be using a 9 volt battery as the voltage source for powering the circuit, not the test battery. So the V in would have been 9 volts in this case, and these were all the calculations I did to get the resistor ratios, and the other challenge was figuring out what Electroluke meant by his resistor ratios. I hadn't seen the R1 over R2 ratio before, so I had to use another formula. I'll talk about that. But there's some algebra. Yay. So once I realized I was going to be using a 5 volt voltage regulator, that's apt for how I was feeling at the time, because I couldn't figure out his math. I then redid the calculations and figured out, based on whatever resistors I had from my 1,000 trips to Radio Shack to get this to work, was able to come up with, I just set R2 to be 1K ohm for each, just to kind of be consistent, and then adapted R1 as needed for the voltage divider. So that was kind of the same calculations, but with a 5 volt input, which is what I ended up using with the Arduino voltage regulator. And then, yeah, so eventually figured out that I guess sometimes we do talk about resistor ratios as R1 over R2. That was what the guy on the video had done, so to be consistent with what his whole setup was, that was kind of the way I went to. So still the same voltage out, but had these different kind of resistor ratios, and that was using this. I had to kind of work backward to figure out some formula. And then same thing, so all the R2s are 1K, and then all the R1s kind of changed a little bit just for the 5 volt input rather than the 9. And then this was what I had to use based on what resistors I had available. So I had a new R1, R2, which were fairly close. I didn't have to go too far off. I was able to be pretty close. And then calculated the V out using handy dandy voltage divider formula. And then measured using a multimeter the V out, which I'll show you in a different video this morning after I had gotten everything hooked up last night. So those were mostly the challenges, was just figuring out how the op amp worked and kind of troubleshooting the breadboard a little bit, which is probably pretty valuable, which I haven't, I guess, really troubleshooted. I just tried to put on a different breadboard and that worked. So I'll go back and kind of see if that breadboard actually didn't work the first one I tried to use. But yeah, kind of exciting. So it worked. Like I said, I'll show you in a separate video the multimeter because I don't have my own. I had to borrow one. But it lights up and powers down and it's pretty and it was fun. Conclusions, I guess, mostly that I think more, well, there are some tangible, obviously, lessons learned in putting this together. I definitely have a better understanding of putting resistors together as well as kind of hooking things up as needed into a breadboard. And learning a little bit about how we can use an op amp as a comparator, non-inverting, inverting input, that kind of thing. But I think most valuably was that I can like do something on my own that I was at a sushi bar reading an electronics book, and it's just really funny to see like people's reactions, and it's still a little awkward. Like I think I just don't really fully believe that like I can do this kind of stuff, but I did it and I'm really pretty proud. And so I think most valuably it was just sort of being able to look up information to get something to work that even though I adapted it, it was still just sort of like, okay, I need to actually do it. And it's not just putting it on paper or talking about it, but making it work. And yeah, just, I don't know, check your breadboard. Check your, the other question that I had when I was trying to put it together was maybe I bought a like bunk op amp, but it was new, so I was like, I'm just going to pretend and kind of hope that it works. The other option, if it wasn't working, was I was going to try to use 4 like little bitty op amps instead of the quad, since that would have been fine too, because it's basically the same thing. But it ended up working, and I got it. Here it is. So I'll stop blabbering now and answer any questions if you have any. Thanks for listening.